All right, everyone, we are back and we are going to go through our beam ball balance lab. So there you can see it right here. So we have our National Instruments DAC. We have our plugin that connects to our Vernier Photogate. So just like we did last time with our, basically with our RPM lab, basically measuring the RPM with the fan. So we're going to use that again. Again, that is plugged into the digital plug here. We have it is controlled, as you can see here, from this linear actuator. So the linear actuator has basically two wires for this one, pretty simple one. It needs 12-volt power supply, so that is wired red into motor A, black into motor B. It doesn't matter which one you do, but it will change whether it's basically based on the code, whether it's going to retract or extend. So important to see here. We have our motor driver as usual. We have our power supply. You can see the 12-volt power supply here. Again, make sure that you don't exceed that because you can damage the material and the equipment. We have our common ground, which is connected here on our breadboard, and that is connected to a common ground, which is on our, basically my DAC. We also have, sorry, I'm going to just plug in here, the DRW, the direction, that's going to be a digital signal now. So we're plugging that into D4 on our my DAC on the screw terminal, and to control with pulse width modulation, PWM, that is going to be controlled with our analog input. It ranges from 0 to 5 volts, and that will basically scale, and we'll actually have to put that in on our code here. So our code, which you've seen before, now you can see my, the code, you can tune essentially that voltage. You can tune essentially, basically if like the ball is stuck in triggering, you can kind of stop the whole system, and you can change debounce time, pull interval, and a bunch of other things within the code. Another important thing is to basically start the actuator. So false is going to be extending, true is going to be retracting, so I want to extend. Now, unfortunately, what's probably going to happen is going to trigger, because I'm actually so extended that I'm going to trigger this, and then it's going to start. So I might have to kind of play some games to kind of get it going, but you can kind of see here, starting the code, extending, but when it triggers, see, now it's going to start to, and it stopped. So actually, I'm going to go ahead and try to run it one more time. Let's see if that works. Oops, so see, now it's in. Let me start it here. So let's go ahead. Let's see if we can go in extend mode. Nope. So we are actually in extend. Yeah, what we're going to have to do, we're going to have to reset this, and then we'll get it going. But you see it's working, and then we'll start to see the ball control in just a second. So see you then. All right, everyone, so I was able to fully extend now. So now we actually want to move in retraction mode. So what I'm going to do, start, and I'm going to say retract. So I'm going to say capital T, true. So we're going to start into retract mode. So I'm going to go ahead and we're going to videotape this. And then we're going to see. Retract, ball moves, triggers, reverses, triggers again, and back and forth. And you can see kind of the balance here. If you do different balls with like higher weights, obviously you'll get a quicker, you can kind of get that response and get that ball moving. But yeah. You can tune parameters as well, and you can kind of play around and see and try to make your code a little bit more robust. If you would like another controller or another kind of optional thing here, and you can do multiple photo gates. You can put kind of basically a visual sensor on the edge here. But yeah, this is our first little control lab. Balance a ball with that feedback from the blocking mechanism. So this is your first little control system. Congratulations. See you in the next video. Thanks. Bye.